Good morning, class. Today we're going to look at rationalizing the denominator of dividing radicals. Basically, when you divide radicals, we do not want to end up with a radical number on the bottom. What that is to say, there shouldn't be a square root sign, there shouldn't be a radical sign in the bottom of the fraction, so to speak, of your quotient. So let us look at this. If we have to divide the square root of 3 over the square root of 27, because both of them are under the square root sign, we can rewrite this such as this is the square root of the fraction 3/27. Then we simplify the fraction and we get the following. Square root of 1 over 9 equals the same thing as square root of 1 over the square root of 9. We all know the square root of 1 is 1 and the square root of 9 is 3. So if we look at our simplification, just like we've been doing, 3 repeat twice because we're looking group of 2's and it becomes 1/3. And that is your answer. Okay, now here's what I would like you to do. Try this one. Okay. Let's see what it is. If we follow the same procedure, well, because both of them are under the square root sign, you would have the square root of 7 over 2/7. Basically what I did have the 28, I break it down. I break down the 28, and now I can simplify the 7, then I am left with, now remember that I'm still looking for a group of 2's because the index is 2. Square root of 1 is 1, and that would leave me over 1 with 1 over 2. Okay? Alright. Now let us look at this. When we are dividing by a radical number, and we cannot simplify or break it down, which means it looks as if it's done, yet we do not want the radical numbers in the denominator. That is why it's called rationalize the denominator. So what we do, we multiply everything by what's in the denominator. Basically, I'm not doing anything but multiply by 1. Think about it. 1 times 5 is 5. If I have any number multiplied by 1, it's still itself. So, because I want this not to be on the bottom, I'm multiplying by 1 in the form, which means I'm not changing it. It's going to simply look different. So I multiply everything by what's on the bottom. I multiply everything by what's on the bottom, which is square root of 3 over square root of 3. Anything over itself is 1. Basically, I'm not changing it, really. So I proceed with multiplying the top with the top, bottom with bottom, and I have 4 square root of 3 and over square root of 3 times 3. As a result, ladies and gentlemen, 4 square root of 3 remains because 4 is outside square root of 3. Then the square root of 3, I'm looking for a group of 2's. It becomes 4 square root of 3 over 3. That is what you have. Or you can write it as 4/3 square root of 3, because 4/3 is the coefficient of the radical square root of 3. Okay. See if this makes sense. If you had to do the same thing, you would need to complete this. The same procedure. Follow the same procedure to complete this, rather. So, you should end up with the following. We multiply everything by 1, which is square root of 7 over 7. And we get 2 square root of 7. And since square root of 7 times 7. And since we're looking for a group of 2's, okay, we get 2 square root of 7 over 7. Or 2/7 square root of 7. Alright. But unfortunately, guys, you know, not all of it are like that. So let's say we have something like this. 7 over the square root of 24. What I suggest is always break it down first. If it is a big number that can be broken down, break it down first. So that you have the following. Break 24, you get this right here. 3, 2, 2, 2. Okay? Now, we break down 24. We're still looking for group of 2's. So since we're looking for group of 2's, there's a group of 2 right there. That means that's going in front of the square root sign. There. So this becomes this. That's good and dandy. But remember, we cannot have radical on the bottom. So let's multiply it by 1. Do not multiply it by everything that's on the bottom. You could, but you would have to do more work. Simply multiply by the square root of 6 over 6. Because what we're trying to do is get rid of the radical number. And we have the following. And ladies and gentlemen, here we are. But we know the square root of 6 times 6. We have a group of 2. So that goes outside and multiply by the 2 that is already outside. So that becomes 7 over 12, 7 square root of 6 over 12, or 7/12 over 6. Alright? So, pause this and try this. Alright, now here's what you should have had. Of course, we break 8 down, and we have the following. We're still looking for a group of 2's. As a result, we have the following. So 2 multiply the 5 that is outside, and there, and we end up with 1 over 10 square root of 2. Again, what is a shame, we cannot have the radical on the bottom. And so we have everything multiplied by the square root of 2, and we get 1 square root of 2 times 10 square root of 2 times 2, with the following. Since we're looking for a group of 2's, there we go. The 2 multiply the 10, and we get square root of 2 over 20, or 1/20th square root of 2. Okay. Let us look at conjugates, because unfortunately, it doesn't stay there. Sometimes we have a binomial in the denominator that contains a radical number. So, ladies and gentlemen, we have to talk about conjugates. What is conjugates? Conjugates is basically an expression that allows us to multiply the binomial in the denominator such that we get rid of the radical signs. It's almost as if you could call it difference of squares. If you remember difference of squares, we can look at that a little to remind you. So the conjugate of 3 minus square root of 7 becomes 3 plus square root of 7. Students like to say, we change all the signs. No, you do not change all the signs. You change the operating sign, such as, you see, 3 minus square root of 7. You don't change the sign for the 3. You simply change the operating sign, such as it was minus square root of 7, it becomes plus square root of 7. Alright? For example, negative 7 plus the square root of 5 becomes negative 7 minus the square root of 5. You see? The only sign that changes is the operating sign in the middle. Okay? This is called conjugate. We're going to see how we use conjugate when we divide by a binomial that contains a radical sign, because we simply cannot have radical sign in the denominator. So, what is the conjugate of 3 minus the square root of 11? What is the conjugate of 6 plus square root of 7? You should be able to tell me what those are. Alright. You should end up with 3 plus square root of 7 and 6 minus the square root of 7. Alright? So let's see how we can use conjugate, how it comes into play really. Now, we have the expression negative 7 over 1 minus square root of 11. Yes, we cannot have a radical on the bottom. However, in this case, we cannot simply multiply by the square root of 11 over the square root of 11. We can't. Because what happened, we would get rid of the square root of 11, where the 1 is, there would be a radical there. So, what we do, we multiply by 1. Still, the whole idea is the fact that we're not changing it, but we're multiplying by 1. But that 1 is the conjugate of 1 minus square root of 11. The conjugate of 1 minus square root of 11 is 1 plus square root of 11. And so, we carry on this manner. So we multiply everything, the numerator and the denominator, by the expression 1 plus the square root of 11. We do the distributive property here for the numerator, and we get negative 7 times 1 plus negative 7 times 1 square root of 11. So we get the following: negative 7 minus 7 square root of 11. That is the numerator. Now, the denominator, we have to do the distributive property as such that we have the 1 minus square root of 11 times 1 plus square root of 11. If you remember, this is difference of squares. But let's work this out so we can see how this works. So the 1 multiply that, 1 plus square root of 11, the negative square root of 11 multiply 1 plus square root of 11. So we do the distributive property for the first one, the distributive property for the second one. Remember, we're just working on the denominator right now. So when I multiply that, 1 plus square root of 11 is 1 plus square root of 11. Remember, ladies and gentlemen, anything multiplied by 1 is simply itself. So negative square root of 11 times 1 square root of 11 becomes negative square root of 11 minus the square root of the product 11 times 11. So, if you look at the last one, it is simply a group of 2. And if you look at the middle two terms, they cancel out. They're exactly the same thing with different signs. So they cancel out. And the last one has a group of 2 of 11. So it becomes 1 minus 11. As a result, the bottom becomes negative 10. Notice that there's no more radical signs. No more radical signs, so we're in good hands. So we're going to rewrite the numerator as it is, and negative 10 on the bottom. So since everything has a negative sign, I can factor out and simplify the negative sign. So I get 7 over 10, 7 square root of 11 over 10. Okay? Which could also be 7 over 10 plus the square root of 11 over 10. But, yes, this is what you end up with. Now, consider this. We do the same thing. We do not change a thing. Because the bottom is a binomial, we have to find the conjugate of 5 minus 3 square root of 2. So, here we are. Since the conjugate of 5 minus 3 square root of 2 is 5 plus 3 square root of 2, we multiply the top and the bottom by 5 plus 3 square root of 2. That way, it's simply multiplying by 1. So, ladies and gentlemen, we do the distributive property for the top again, and distributive property for the bottom. And we end up with the following. That's the numerator. The denominator, if we do it, and pay attention carefully because it is the difference of squares you should end up with, and there's a radical, you will end up with 5, the first one. No, that should be 25, excuse me. You should end up with 25 second here. You should end up with 25 minus 9 times 2. That's what you will end up with. Once you end up with that, because what you did, you take the first one times itself, then the number that's not on the radical times itself, and the radical times its coefficient. You get the number under the radical, which becomes just 2, times its coefficient that's already there. So, ladies and gentlemen, what you end up with, 10 square root of 6 plus 12 square root of 3, because we break 12 down and bring the number out, and on the bottom, what we end up with, this becomes 25 minus 18. Okay? This becomes 25 minus 18. So, excuse me, 25 minus 18 is a positive number, and that gives you, what is it, 7? Alright, that would give you 7. Alright, this is what you end up with. Notice that there is no radical at the bottom of this. Alright? Questions? Please comment and ask questions if you do not understand. Now, I would like you to try the following. Look at the things we have. Actually, try them. And let us see what you come up with. Thank you.